Hello everyone, my name is Christos Bisias. I'm a software engineer from Greece and I'm part of the G-Research open source team. G-Research is a leading quantitative research and technology firm. The company is heavily investing in and using open source software, and the GROS team, the open source team, which I'm part of, is trying to leverage open source software to solve business problems. Now, a few words about me. I've been contributing to open source projects on behalf of G-Research for the last 3.5 years. And in the past 1 year, I've been doing a lot of work around OpenTelemetry and Airflow. I also adjusted Airflow's OTel implementation to make it support context propagation, which is something we are going to talk extensively later. So what are we going to talk about today? What is OpenTelemetry? Why do we want to use it with Airflow? What do we have to gain out of it? And we are going to discuss the OpenTelemetry basics like traces, spans, data, context, context propagation, the mechanisms, and at the end, I'm going to do a demo where I'm going to execute an Airflow DAG that exports subspans. And one of the tasks is actually going to make a call to a running Spring Boot application that's going to be on the same network, and that will also export a span, make us track the operation. Hopefully, by the end of this presentation, people should be able to create their own spans and add them to their DAGs. So, a very common question: why is my DAG slow? Why is it still running? Now, we can look at the web server UI and we can have information about the DAG run and the tasks and how long it took, how long the DAG run took, how long the task took. But what happens if you have tasks that can run for multiple hours? The task itself is a black box. There is no visibility under it. You have no idea how long each step of the task took. Now, this is what we are trying to solve with OpenTelemetry. We're trying to monitor the task and understand it. Now, I've been throwing the word OpenTelemetry around, and now it's time to explain what it is. OpenTelemetry is a collection of open source tools that can be used for collecting data like traces, logs, and metrics. Now, all this data is later exported to visualization backends like Prometheus, Grafana, Jaeger, Aspire Dashboard, and a bunch of others. This presentation is going to focus on traces because the logs and metrics deserve their own presentation. Now, OpenTelemetry is very widely adopted and supported, and the main reason is that it's technology agnostic. It has a different implementation, a different client implementation for its programming language, an SDK for Java, Python, Golang, etc. The OTel SDK can be added as a dependency to an application, and then we can use that to export data and track operations, which is very useful, especially in distributed systems when an operation can start in one place, like a task, and then we can have a database call or an API call and move to another service, and we have no idea how long that takes. Now, let's explain a bit traces and spans. Let's assume that we have a very large operation which is consisted of multiple small steps. Now, the entire operation is going to be considered a trace. All the collection of the steps is going to be a trace, which in Airflow context is a DAG run, and each individual step is going to be a span, which in Airflow context is a task. Each task is going to be a span. Now, this is what the common visualization backends show for traces and spans. This is how they depict them. So we have everything is organized in a tree view with parent-child relationships, and we have a root span which shows us the entire DAG run. And if you can see all these individual spans, all the blue lines are spans. All the spans together, they form a trace. We have the root span, which shows us the entire operation, which is going to be an entire DAG run from start to finish. And then each DAG run has its own tasks. Each task it's going to be an individual span, and it's going to be a children of the root span. Now, why do we want to use OpenTelemetry? The thing is that the data that I showed earlier, this data, we can, if we enable OpenTelemetry in Airflow config, this is what we get. But this is the basic data, and this is exactly what we get from the web server UI. We already know from the web server UI how long the diagram took and how long its task took. But with OpenTelemetry, we can create our own spans and monitor parts of the code from other tasks. And like I said earlier, we can monitor external calls to public APIs or any other service that interacts with our DAGs. Now, each span has some data, the trace ID, the span ID, and the parent span ID. These data together, they form the span context. Spans that all have the same trace ID, they belong to the same trace. So if you can see here, with the green, these all have the same trace ID, and so they belong to the same trace. And they are organized together in that tree view. Now, each span ID is unique, and we set the span ID to the parent span ID, and that's how we know that we have this parent-child relationship where one is the parent and the other is the child. And if the parent span is null, then that's how we know that we have the root span, the start. Like, for example, the root span of a diagram, which is the start, it's going to have a parent span null. And we know that span 1 and span 2 are children of the root span because they have the same. The parent span ID points to span 0. And the same goes for span 3 and span 4 because the parent span ID points to span 1. Now, OpenTelemetry has a philosophy, has a philosophical idea, a specification that should be followed. The thing is that spans are thread local. We cannot share them outside of a service, and the objects cannot be shared and they cannot span. So for each service that you have to create a different individual span. And let's see here. So for example, if we have task 1 and task 1 ends, the process exits and then it does an HTTP call to another API and delegates all that, delegates the context, we cannot have the span object shared. We cannot move it on to the API. It cannot continue there. We are going to have to create a different span. Now, if you can see in the third part here, if the API call does the response back to task 1 and the thread continues to run, we can continue with span 1. Otherwise, if it's like this, we cannot. Now, we can create span for the task, and then we can create a different span for the API call, and then we can associate them with each other. But the question is how we are going to associate them. We are going to do that with context propagation. Now, context propagation is the method of sharing a span's context across different services. The context is then used so that we can let the new span know who the parent is. Like task 1. Task 1 is your parent. The context follows the WC3 specification and looks like this. We have the trace ID and the span ID, and this is of the current span. Now, this is later exported into a dictionary. We have common mechanism of achieving context propagation, but that depends on the protocol of communication. Like, for example, if you have an HTTP call, then you are going to get this here, you are going to get this, and you are going to pass it in the HTTP headers. If you have a gRPC call, you are going to pass it in the metadata. If it's a message queue, you are going to set it within the message. But depending on the system, you could also have custom mechanisms. Like, for example, in Airflow, the only common point of communication is the database, is the metadata database. So in order to associate the spans of the children of the spans created under the task with the task span, we are doing it through the database. So we are storing the context of the span for each task into the database and then retrieving it from the task itself. Now, we can capture and export spans with two ways. We have auto-instrumentation and manual code. They both have their pros and cons. Auto-instrumentation how it works, we have instrumentation libraries, and these instrumentation libraries, they are injecting telemetry code into our application, and the telemetry code is actually monitoring very popular operations and frameworks like a database call or an API call, and it's automatically capturing data and exporting the spans. Like we can monitor a get call or a post call. Now, if the code is something that the instrumentation library hasn't been designed to monitor, then it won't export any data. And that's why this approach is very strict, but we don't have to add any code ourselves. We're just going to have to hook the auto instrumentation library as a dependency. In manual code injection, the user has to write the code, but this approach is very flexible, because we can monitor whatever we want, whatever code block we want, whatever method, whatever call. Now, let me explain the setup of this demo. So I have Airflow with OpenTelemetry traces enabled in the configuration. I have a common hotel collector service running. Jaeger will be used as the visualization backend for the traces, and there's going to be a Spring Boot application running, which is going to have the hotel SDK for Java added as a dependency. Now, both Airflow and the Spring Boot application, they are going to create spans, and one of the tasks is going to make a call to the Spring Boot application, and it's going to propagate the context, and that's how we are going to monitor the operation. Now, all of these spans are going to go to the common hotel collector, and the hotel collector will forward them to Jaeger. Now, the tasks, we are going to create some subspans with context propagation, which we are going to receive from the database from the task instance that we have stored in the database. Also, I am hooking the auto instrumentation library in order to monitor a GET request to my GitHub repos. And then it's going to be the call to the Spring Boot application. Here's an example of how we can create a span from under a DAG. So the task, we have the TI in the context, and from the TI we get the carrier, which is a dictionary that has the trace ID and the span ID. This is actually using the propagators API to extract it, and it extracts the data and creates the context. This context belongs to the parent. It actually belongs to the task. And so when we start a new span and set the parent context here so that this knows that the task span is the parent, and this is a direct child of the task span. Actually, here I'm using a context manager, and this is the context manager is going to wrap a code block, and whatever goes under the code block is going to be part of the span. When we exit the code block, the span is going to automatically end. And this is an example of the code where I'm actually getting the carrier here, but instead I'm just passing it in the headers while doing the GET request to the Spring Boot application. And now the Spring Boot application is going to be responsible for extracting it just like above, but it's going to do it in Java. The methods are the same, the API is the same, but it's a different language implementation. It's going to be responsible for extracting it, and then using that in order to create the subspan and associate with the parent so that we know that belongs to task 2. That's a child of task 2. Now here I would like to run this directly. I've run the DAG here, and this has finished, and then I'm going to go over to Jaeger. I'm not going to run it again, so that we don't have to wait it. And here in Jaeger, we have the services. Now, the Airflow name is configurable. It has to do with Airflow configuration. You can change it. And also, I named the Spring Boot application Java tester so that we know that we are going to a different component, but you can also change that and you can give it the same name as you have done in your Airflow components. And that way, it's all going to be the same. You want to understand the difference, it's all going to have the same color. And this is the result. Now, if you see, we have this information from the web server UI. We know from the web server UI that it took 15 seconds to run. We know that task 1 took 2 seconds and task 2 took 11.39. But right now, we can monitor the external call to the API. We know that that call took 10 seconds. And like I said, I used a different component name so that it can be a different color, it can be yellow, and we can distinguish it and know that this went somewhere else to execute. And from under task 1, I've created subspans with different ways. The code is going to be available for anyone who want to see how to set this up and how you can create your own spans. But I try to follow different methods here so that you can get an idea. So here I've added some next topics to research for anyone interested in order to find out more of how you can create your own spans. Now, the first one, OpenTelemetry SDK initialization, how you can initialize an SDK after you've added it as a dependency into your project. When to use a simple and batch processor and what's the difference, span processor, and what's the difference between these two. Span attributes can help you expose data from the moment that you are creating the span, and you can view them into the visualization backend. The propagators, the inject and extract methods, they are used for getting the span context and then extracting it. What is the SDK static context variable? This is useful when switching between different spans from parent children and trying to create the right relationships. How you can do auto instrumentation, how the library will work, and then OpenTelemetry metrics and how you can visualize them, how you can send them all to Prometheus, and then Prometheus can forward them to Grafana so that you can visualize them. And that's it. The QR code, you can use that in order to get the demo code that I used, and you can get a basic idea about how to set this all up. I've used Docker for this setup, and then I've added comments in the DAG of how you can create spans and why I'm doing each part. Thank you very much.